Hi, my name is Lisa. In this video, we'll be talking about how to solve linear equations. We'll start with the addition property, but first I want to just define what a linear equation is. A linear equation in one variable can be written in the form ax plus b equals c, where a, b, and c are real numbers, and a is not 0. Some examples of linear equations are 3x plus 2 equals 5. Another linear equation would be x minus 7 equals 9. And a third example, 1/2 x plus 8 equals 9/2. Some examples of nonlinear equations would be things like 5x squared plus x minus 1 equals 0. The part that makes this nonlinear is the exponent on our variable. The square root of x equals 10 is also a nonlinear example. The x is under a radical. That makes it not a linear equation. And my third example in this video is going to be 1 over x equals 7. We can have fractions in our linear equations as long as the fractions involve real numbers in the denominator. If you have a variable in the denominator, that makes it nonlinear. We'll talk about the addition and/or subtraction property of equality next. If a, b, and c represent real numbers, then a equals b and a plus c equals b plus c are equivalent. In other words, you can add or subtract the same amount to both sides of an equation without changing its solution. In the definition here, we've added c to both sides of the equation. When we talk about the sides of an equation, we talk about the things on either side of the equal sign. That's what divides the equation into the left-hand side and the right-hand side. In order to solve example number 1, we need to figure out how to get x by itself. In this example, since I have x minus 3, I want to add 3 to both sides. What that leaves me with is x, and negative 3 plus 3 is 0. So I have just x on the left-hand side of the equation, and on the right-hand side of the equation, 14 plus 3 is 17. And that would be my solution to this particular equation. Oftentimes we write the solution as a set, and we would say the solution is the set of 17. So you may see this when you start doing the online homework. Example number 2 says 8 plus x equals negative 11. This is a positive 8, although we don't normally write the sign there. So in order to move 8 to the other side to get the x by itself, we're going to subtract 8 from both sides of the equation. And again, the sides are what's to the left and to the right of the equal sign. If I subtract 8 from both sides, 8 minus 8 is 0 plus x, leaves me with x, equals negative 11 minus 8 is negative 19. And there's our solution to example number 2. Example number 3 says 5 equals x minus 7. Again, I want to get the x by itself. I'm going to add 7 to both sides of the equation. So if you notice here, addition and subtraction always go together. If I'm adding and subtracting the same number, it always adds up to 0. And it could be a number or it could be a quantity. It could be x that I'm adding or subtracting. But anytime I add or subtract that same quantity, it becomes 0. So what I have here is 5 plus 7 is 12 is equal to x minus 7 plus 7 is 0, so we have just the x by itself, and there's our solution to the equation. X minus 6.9 equals negative 2.1. In this example, here's my equal sign, I'm going to add 6.9 to both sides of the equation so that I can get the x by itself. Again, minus 6.9 plus 6.9, those add up to 0. So I have x equals, and now when you're doing positives and negatives, oftentimes it helps to put the bigger number on the top, and this is a positive 6.9 minus 2.1. 9 minus 1 is 8, and I keep my decimal points in line. 6 minus 2 is positive 4, so we wind up with x equals 4.8. Now you can do the arithmetic on the calculator, and I'll pull up a basic calculator here. If I have a negative 2.1 plus 6.9, it gives me a positive 4.8. So you can use your calculator or you can do those arithmetic problems by hand. And just a reminder for you here, the goal of solving linear equations is to get the variable by itself on one side of the equal sign on everything else, or in these examples, all of the numbers on the other side of the equal sign. The multiplication property of equality says if a, b, and c represent real numbers and a is not 0, then a equals b and ac equals bc are equivalent. In other words, you can multiply both sides of the equation by the same amount without changing its solution. In this example, we've multiplied both sides of our equation by the value c. We're going to do that with some example problems here. Example number 1 says 1/5 x equals 4. Remember, our fraction bar tells us we're dividing by 5. What goes with division is multiplication. If I want to clear that fraction, I'm going to multiply both sides of my equation by the denominator, in this case 5. If you think about that, 5 is the same as writing 5 over 1, and when we multiply fractions, we go straight across. This gives us 5 times 1 is 5, and 1 times 5 is 5, and 5 over 5 is 1. So in other words, what we usually do is say if we're multiplying and dividing by the same number, or in fractions, if we have same factor in the numerator and the same factor in the denominator, we cancel them out because it's equivalent to 1. So this leaves us with x equals 4 times 5, or 20. So we're going to use that property of 1 quite often here to help us simplify our equations and get rid of fractions. Example number 2 says negative 2 equals x divided by 3. Again, we're dividing by 3, so to get rid of that denominator, we're going to multiply both sides by 3. So we're multiplying by 3 and dividing by 3, those cancel out. And we're left with x on the right-hand side. On the left-hand side of the equation, 3 times negative 2 is negative 6. Notice, it does not matter which side of the equal sign the x is on, as long as we have x by itself in our final answer. Example number 3 says 7 equals 4x. Remember, 4x really means we have 4 times x, and what goes with multiplication is division. If I want to get rid of that 4, to get the x by itself, I need to divide both sides of my equation by 4. And I get 7 over 4 equals x. Again, those 4's are going to cancel each other out. And we're going to do the same thing in example number 4. Negative 0.8 times m equals 16.8. I'm going to divide both sides of my equation by 0.8, or that looked a little messy, negative 0.8. Sometimes when I'm writing these by hand, I leave out that leading 0 just because it's a little bit easier to read. So on my calculator, if I have 16.8 divided by negative 0.8, and that was not right. This is an example of making sure that you know how to use your calculator. I hit the subtraction sign on that example instead of changing it to a negative number. What I should have said is 16.8 divided by 0.8, which is a negative 0.8, and then hit my equal sign, and I get negative 21. So make sure you know how to use your calculator. M equals negative 21. And sometimes I still make those mistakes. I have a subtraction sign on my calculator, and I have a sign here to make it a positive or negative number. I just have to make sure I'm hitting the right symbol on my calculator. Example number 5. Now this one looks a little bit different, but it's still the same principle. We want to get rid of that denominator. In order to get rid of the denominator, we're going to multiply both sides of our equation by 11. And I am going to use my calculator again here when I have larger numbers to work with. So here when I multiply by 11, my 11s cancel out, leaving me with 4x equals 16 times 11. This is where I'm going to use that calculator. 16 times 11 is 176. And then to get the x by itself, I have 4 times x. So what goes with multiplication? Division. I'm going to divide both sides of my equation by 4, and that leaves me with x equals 176 divided by 4, or 44. And in example number 6, our denominator on both sides of the equation is 8. I'm going to multiply both sides of the equation by 8. And when I multiply by 8, that denominator, or where I'm dividing by 8, cancels. And I have negative 7x equals 5. To get x by itself, negative 7 times x means I have to divide by negative 7. And I want to divide, I want to keep that negative sign with my divisor because I want them to cancel out, leaving me with a positive x, or just plain x. Does not matter where the negative sign is, that means I have a negative 5/7. As long as I have just one negative sign, my answer is a negative number. Now there are 2 ways to solve an equation if the coefficient of the variable is negative 1. And I'm going to show you in these examples the 2 ways to do that. One is, this really means we have negative 1x equals 6. And we always, when we're multiplying our variable by a constant, we always divide by that number. Negative 1 is what we're dividing by. Negative 1 over negative 1 cancels, leaving with x equals 6 divided by negative 1 is negative 6. So you can divide both sides of the equation by negative 1, or, as I show you in the next example, it works the same way if we multiply both sides of the equation by negative 1. Negative times negative makes that positive, and 1 times p is p. Negative 9 times negative 1 is positive 9. We really need our variable to be a positive. And I made a mistake on this example when I copied it over, so I'm going to rewrite that right now. Should say, and this should match what you have in your notes, 4x plus 4 equals 3x. To solve this equation, I am going to use my addition property of equality first. I need to get all of my x's on the same side of the equation. I have a positive 4x on the left. I'm going to subtract 4x. I want to leave that 4 by itself. So I'm going to subtract negative 4x. 4x minus 4x is 0, so we can cross that out and we're left with 4 equals 3x minus 4x is negative 1x. Where I have that negative 1 as my coefficient, I can always multiply or divide. Pick one way and stick with it. I like to divide. That's how I learned to do these. So I divide by negative 1, and I'm left with x on the right-hand side, and 4 divided by negative 1 is negative 4 on the left. And there's my answer. Now, it doesn't do this in your workbook, but I want to show you that you can always check your answers. You can go back to the original equation, and our original equation on this one was 4x plus 4 equals 3x. Wherever I have x, I'm going to substitute in what I got as my answer. Okay, and I'm going to see is what I have on the left-hand side equivalent to what I have on the right-hand side. So if I replace x with -4, I'm going to have 4 times -4 plus 4. 4 times -4 is -16 plus 4 is -12. On the other side of the equation, when I replace x with -4, and I always wrap it in parentheses when I do that, 3 times -4 is -12. The left-hand side is equal to the right-hand side, so check. I know I have the correct answer. My correct answer is x equals -4. When you're solving equations, you should always simplify each side first. So, in other words, if there are like terms on one side of the equation, you want to combine those like terms first. In example number 1, 3y equals -26 plus 17. -26 plus 17, those are both strictly numeric. I can add those two numbers together. When I do, I get 3y equals -9. I've simplified my equation. Now I can use my multiplication property. 3 times y. In order to get 3 by itself, I want to divide by, in order to get y by itself, I want to divide both sides of the equation by 3. 3 over 3 is 1, so I'm left with 1y equals -9 divided by 3 is -3. In example number 2, if you notice the left-hand side of the equation, all of these are x terms. They are all like terms. And remember, x means, even though we don't usually write it, it has a coefficient of 1. So when we combine our like terms here, we're adding our coefficients and keeping the variable part the same. So 5 plus 7 plus 1 is 13. So we have 13x equals -13. Again, I'm going to use that multiplication property. 13 times x means I want to divide both sides of my equation by 13 so I can get the x by itself. 13 over 13 cancels, and I have x equals -13 divided by 13 is -1. And that concludes this video on solving linear equations.